Saturn, a gas giant, is the sixth planet from the Sun and the second largest planet after Jupiter in our solar system. Saturn is composed predominantly of hydrogen and helium and is adorned with magnificent rings. These rings are composed of countless particles of ice and rock. These tiny ice crystals and larger chunks of rock are kept in place by Saturn's immense gravitational pull. But a startling discovery has shaken our understanding. There's a strange and captivating phenomenon linked to these rings. They appear to vanish from our view at regular intervals. This disappearing act isn't an illusion, but rather a remarkable cosmic event known as Saturn's ring plane crossing. The disappearance of Saturn's rings will not only alter our scientific understanding of planetary ring systems. The rings of Saturn are the most extensive and complex ring system in the solar system. Saturn's rings are not solid structures. Instead, they are composed of countless particles ranging in size from tiny ice grains to massive boulders that orbit around Saturn. These particles are mostly ice, with a sprinkle of rocky material. Each particle orbits Saturn independently, creating the illusion of a solid ring from a distance. The rings are incredibly thin, despite their vast width. If you could somehow stack all the ring particles together, they would barely reach the height of a skyscraper. The discovery of Saturn's disappearing rings was not a sudden revelation. It unfolded gradually through many decades of observation and meticulous data analysis. As the planet orbits the Sun, it also rotates on its axis, much like Earth. This cosmic dance results in an extraordinary event every 13 to 15 years, where Earth passes through the plane of Saturn's rings. From our perspective, the rings, usually a prominent feature, appear to thin out and eventually vanish. The rings don't actually disappear. They're so thin that when viewed edge-on, they reflect very little light, becoming nearly invisible, even to powerful telescopes. The next ring plane crossing is fast approaching in March 2025, when we'll have the chance to witness this incredible cosmic event. Have you ever thought, what would happen if Saturn lost its rings? Without its rings, Saturn's temperature could increase, as more sunlight would be able to reach the planet directly. Additionally, the rings play a crucial role in maintaining the gas giant's atmosphere. A temperature rise would have devastating effects on any planet. These rings stretch over 175,000 miles from the planet's center, nearly the distance between Earth and the Moon. Despite their vast expanse, they are incredibly thin, less than 30 feet vertically on average. To put that in perspective, if Saturn were shrunk to the size of a basketball, its rings would be about 10,000 times thinner than a sheet of paper. Some theories suggest that Saturn's rings were once much larger and more brilliant, gradually losing material over time. Jupiter, Uranus and Neptune all have faint rings today, but it's possible that they too once had more prominent ring systems. The early solar system was a chaotic place with frequent collisions and impacts that could have created temporary ring systems around many planets. Over time, these rings may have dissipated, leaving only the faint remnants we see today. This remarkable thinness is why the rings seem to vanish during the ring plane crossing. When viewed edge-on, the light they reflect is minimal, making them nearly impossible to discern from Earth. As we approach March 2025, Saturn's rings will continue to slim down until they reach their thinnest point during the crossing. Saturn also boasts a fascinating family of moons. It has 146 known moons, 63 of which have formal names. From the geysers of Enceladus to the methane lakes of Titan, Saturn's moons are a treasure trove of scientific discovery. Some moons of Saturn, including Pandora and Prometheus, act as shepherd moons to confine the rings and prevent them from spreading out. You still have time to enjoy Saturn's rings in their full glory. In 2024, the rings are tilted at an angle that offers excellent viewing. To observe them, you'll need a telescope. While Saturn itself is visible to the naked eye as a bright golden yellow star, a small telescope with a magnification of around 30x is enough to resolve the rings and appreciate their structure. Numerous stargazing apps can help you find Saturn in the night sky based on your location. Italian astronomer Galileo Galilei was the first to observe Saturn's rings through a rudimentary telescope in 1610. However, his instrument wasn't powerful enough to observe the rings clearly, so he described them as ears or handles on either side of the planet. He mistakenly believed that Saturn's slightly irregular shape was due to two moons on either side of the planet. It wasn't until 1655 that Dutch astronomer Christian Huygens, using a more advanced telescope, correctly identified the rings surrounding Saturn, and the rings were truly seen for the first time. Huygens also discovered Saturn's moon Titan. Since then, astronomers have studied Saturn's rings with ever more sophisticated instruments, uncovering new mysteries. Pioneer 11 made the first flyby of Saturn in September 1979, when it passed within 20,000 kilometers of the planet's cloud tops. The spacecraft also studied Saturn's rings, and images were taken of the planet and a few of its moons. One of the most fascinating discoveries is the presence of shepherd moons. These small moons orbit within or near Saturn's rings, their gravity shaping and confining the ring particles, preventing them from dispersing. Another mysterious phenomenon is the appearance of spokes, temporary radial features in the rings that resemble bicycle spokes. These are believed to result from interactions between Saturn's magnetic field and charged particles in the rings, although their exact origin remains unclear. As we approach the next Saturn's ring plane crossing in 2025, we can only imagine the countless wonders waiting to be discovered.